Nowadays, the high-tech market has seen a massive influx of hyper-realistic interactive robotic dolls with integrated artificial intelligence, which represent an entirely new type of object for interaction with humans. These robot dolls are successors to animatronic robots, but the main difference from such mechanisms is their incredible realism and the presence of artificial intelligence, fundamentally altering the level of interactivity, function, and nature of interaction. Robotic dolls can only interact within the framework of a predefined social role. Their personality, preferences, behavioral patterns, and speech strategies are predetermined by developers. Researchers note several potential negative consequences, including emotional attachment, desocialization, and the formation of alternative models of social relationships. A separate issue is the discussion of the threat to confidentiality and privacy protection, since robotic dolls are connected to the network to receive updates and store user dialogues. It should be noted that social robots with anthropomorphic interfaces have been used for several years in human communication in various roles. Meet Alan, a robot created by engineer Will Huff and his team on the YouTube channel Will Huff. Alan possesses various abilities, including the capability to learn about the surrounding world, interact with people, and even participate in various experiments. The robot represents a project in the development of artificial intelligence and robotics, which is constantly evolving and improving by its creators. A human-scale robot head and shoulder designed to use emerging technologies such as deep learning AI, object recognition, facial recognition, and motion tracking. The robot is fully compatible with today's smart speaker devices like Google's Home, Amazon's Alexa, and even Apple's Siri. The robot is built on an aluminum frame for strength and lightweight mobility. The high-temperature epoxy shells are designed to be resistant to higher temperature environments. Skins are manufactured with platinum silicone for longevity and endurance. The magnetic and modular design allow for future upgrades. The Dry Erect robot, designed for learning and acquiring human skills, was custom-made by Tokyo Robotics. Each joint is equipped with a high-resolution torque sensor, and its surface is made of a gel-like material similar to human skin. The robot's movements are smooth, and it can perfectly mimic human movements. Currently, based on the Dry Erect robot developed as part of the project, researchers are working on creating intelligent robots that will assist people in manual tasks, especially household chores. Household tasks, such as drying and folding laundry, have been solved by coordinating the robot's hands. However, it can be difficult to distinguish clothes with different tactile textures, such as silk and wool. Additionally, there are many complex problems associated solely with household work, such as mastering cooking skills using various ingredients, taking out the trash, and cleaning methods that need to be adapted to the environment, such as floor washing. The Dry Erect robot can also identify clothes dried in different ways and positions, and perform actions such as bending and straightening the robot's arm, grabbing and lifting clothes. The rapid advancement of technology, especially artificial intelligence, is making robots increasingly intelligent. Let's meet one of the smartest robots named Alter, which operates based on neural network algorithms. This means that all of its erratic and disorderly movements are entirely independent of any human control. You could say it's alive. Alter appears dressed in a stylized costume for performance, but the most interesting part is underneath this shell. Alter has 42 pneumatic actuators and a central pattern generator, which creates neuron equivalents and enables the robot to move. Alter's erratic movements are based on sensor readings, which can detect noise, temperature, humidity, and proximity to other bodies. Alter was created by two robotics labs from Tokyo and Osaka, and recently it was showcased at an exhibition at the National Museum of Emerging Science and Innovation in Tokyo. The robot has two modes of movement, chaotic and smoother. The neural network decides which mode to use based on the information it receives from the sensors. By calculating the parameters of the surrounding environment, it performs certain movements. For example, if there are many people around, the robot actively moves its torso. Meet Agrobot, a robot for picking strawberry. In the modern world, robots no longer seem unusual. They are gradually replacing human labor in various sectors, including agriculture. There are robotic farms, drones for field scanning, and automated platforms for soil research and processing. Now machines capable of harvesting crops are starting to appear. The company Agrobot has developed a system with a set of manipulators capable of finding strawberry bushes, determining the ripeness of the berries on them, and picking the ripest ones. The Agrobot robotic strawberry harvester is an unmanned robot for strawberry picking. Agrobot can autonomously harvest berries in an area of up to 80 square kilometers in just 3 days. The selection of berries is determined by size and color, which are identified by sensors on the robot. Ripe berries are harvested extremely gently. The robot does not touch them but simply cuts them off along with a short stem. After that, the robot sends the berries to a special container. The machine is fully automated and performs all operations independently. It moves between furrows and rows using a laser locator. It also has a built-in remote control function for farmers who are concerned about system failures. The device's design allows it to be optimized for any farm's characteristics. Here is one of the most advanced artificial intelligence-powered transportation devices developed by Toyota. The Toyota concept, iWalk, is a personal transportation vehicle designed for areas where the use of cars is prohibited. Essentially, it is an equivalent of a gyro scooter, but with 3 wheels and a control joystick intended to reduce the driver skills required. Even elderly people can operate the Toyota concept. Moreover, as the speed increases, the concept iWalk expands, increasing the wheelbase for additional stability. The range on a single charge is from 10 to 20 kilometers, and for communication with artificial intelligence, a display in the form of a sphere on top of the joystick is provided. Toyota has announced that it will begin testing vehicles with the AI agent system on Japanese roads later during this year. Japanese company Enowave has introduced its high-speed collaborative robot Kobata. The new collaborative robot Kobata is a high-speed robot that ensures productivity and safety. Kobata is an ultra-lightweight collaborative robot weighing only 4 kilograms excluding cables and has a payload of ½ kilogram. Programming is simplified due to a graphical user interface that is easy to install and intuitively operated. Tasks can be automated in a short time and include simple assembly, classification work, and inspection. It is equipped with a direct teaching function, allowing a person to teach the robot movements by directly moving its arms, so anyone can teach the robot new movements without programming knowledge. Kobata can also be remotely controlled using a tablet PC touch panel. The robot is suitable not only for replacing simple assembly, sorting, and inspection tasks, but also for labor-intensive tasks, and by deploying Kobata, a flexible production line can be built. Japanese pub chain Yorinotaki has begun testing a robot bartender capable of pouring beer or mixing cocktails in 40 seconds. The robot is created by QBIT Robotics Company. It consists of a robot arm system that pours and serves drinks, a tablet displaying the robot's emotions, and 4 cameras that locate customers and determine their mood. It takes the machine 40 seconds to pour a beer and 1 minute to mix a cocktail. The robot can recognize customers' faces and use voice calls based on their age and gender to attract clients. To analyze customers' facial expressions, the robot uses a computer vision system and 4 cameras. While the mechanical bartender lacks speed, introverted Japanese people like the novelty of the new employee. There is no need to engage in lengthy conversations or attract its attention to order a beer. The cost of the robot is $82,000. This development could trigger a wave of automation in restaurants and cafes, where young Japanese people are reluctant to work. Write in the comments which of the robots shown in this video impressed you the most. Don't forget to like this video and subscribe to the Karo Show channel. Also check out our previous videos. See you next time.